welcome to my Kotlin crash course. First of all, I really want to thank you, Brad, for giving me that opportunity. That is nothing I can take for granted. And if some of you really like my way of teaching here in this course, then you can check out the first link in this video's description. There you'll find the link to my channel. I do all kinds of Android development using Kotlin from beginner to advanced, for example, a running tracker app or a news app. And yeah, if you are interested in that, just check it out, you will like it. And regarding Android, I also plan to make another course where we'll just apply the knowledge from this Kotlin crash course here to make a very simple Android app. And I guess when that is out, Brad will just link to that under this video as well. So why would you actually learn Kotlin? It's not that popular yet, but it is one of the most trending languages out there at the moment. So the number of users is rising so quickly. So right now it is mainly used for Android development just because Google gives it first-class support for Android and just pushes it really hard. But it's also getting more and more popular just for big enterprise applications, and it is, in my opinion, on a good way to replace Java in future. So if you're new to programming, Java is just a programming language that is super spread in the industry, but it is also a very old language. And there are just nowadays many more modern languages, for example Kotlin, that just do a lot of stuff much easier than these old languages like Java. And one reason why Kotlin is becoming so popular is that it is fully interoperable with Java. So those two languages compile to the same bytecode, and that means deep down on a system level we cannot differentiate if a program was initially written in Kotlin or Java. And that allows us, for example, that we can use all the Java libraries out there in Kotlin as well. And that is a big benefit because, as I said, Java is an old language and there are very many libraries out there. And we can just reuse them in Kotlin now, which is a modern language. So if you're new to programming and don't know what a library is, that is just a pre-written piece of code somebody else wrote that you can easily include in your project, so you don't need to write that code on your own. Then a second big advantage of using Kotlin is that it really does not need a lot of lines of code. So again, the comparison to Java, just because that is, in my opinion, the main competitor of Kotlin or the main language we can compare it to. Often, if we would write a program in Java and let's say that would take 4,000 lines of code, then it wouldn't be unusual if we would write the exact same program in Kotlin that it needs like 2,500 lines of code or even 2,000. So 40 to 50% less lines of code just by using Kotlin is not unusual. And there are actually many more advantages of Kotlin that are more of technical nature, which we will discover in this course. Okay, so what do we actually need to start with Kotlin? If we would make Android apps, we would install a program called Android Studio, which we don't do here because we don't want to make Android apps that would just require Android background, and we really just want to focus on learning Kotlin here. And that is why we will use a program called IntelliJ. That is an IDE, so an integrated development environment. That is just a program that makes it very convenient for us to write our code. And installing that is actually very easy. We just want to open our favorite browser here, and don't worry, Microsoft Edge is not my favorite browser. That is just a virtual machine here to show you that setup part. We want to search for IntelliJ download, and then you will see this page from JetBrains.com. We click on that first result here, and you can see we have two options, the ultimate version or the community version. The ultimate version is paid, so we don't want that, we don't need that. That is just really professional software. Community is completely fine for us, that is free. We can just click on download, then it should start. We need to click on save here. It will take a couple seconds and then I'll see you. Okay, once that download is finished, we want to click on run to run the installer. Then wait a little moment. We need to accept something here. Okay, and there we go. So that is, as I said, a very simple setup here. We just want to click on next. You can choose a destination folder, so where you want to install that program to. I will just leave that as it is and click on next. Then we can choose if we want to create a desktop shortcut. I will just do that here for the 64-bit launcher. We can update the context menu. We don't want that. You could create associations for file endings so that you can just double click on those files and IntelliJ will open these files. I'll also leave these unchecked and the rest as well. So we will just click on next here, click on install, and then the program will install, and I will see you after that. Okay, so once the setup is finished, we can check the checkbox here to run IntelliJ and click on finish. You can see there it is. We could import settings here if we would have a previous installation of IntelliJ, then we could just import our old settings. We don't have that right now, so we want to check do not import settings. We click OK. And then wait a little moment, and now it comes to the decision if you want to become a real programmer or not. Real programmers choose the dark theme. Now, of course, choose whatever you like here. I'll choose dark theme. We click on next. Then you can see we could modify some pre-installed tools here, which are all pretty advanced. We don't want to touch any of these right now, so we just click on next to featured plugins. These are just also plugins that you can install to your IntelliJ IDE that assist you with programming. We also don't want to touch these, so we just click on Start using IntelliJ IDEA. And then this window should open for you. Hopefully it does. And here you can see we can now create a new project, which we want to do here. We want to just create a project in which I will show you the basics of Kotlin so that you are ready to use it. And you can see we have several options here. But before we can actually create a project here, we need to install one more thing, and that is the so-called JDK. That stands for Java Development Kit, and that is just a toolkit that we need to be able to run Kotlin and Java programs, or to develop them actually. And for that we want to go back to our browser. I'll open a new tab here, and we want to visit adopt-openjdk.net. So there are several versions of this JDK here. One is by Oracle, so the actual creators of Java, but that shouldn't be used here because that is paid. So if you, not really paid, but if you want to publish something that you made with Oracle JDK, then you need to pay for their license basically. And this OpenJDK is the free version of that, so you can just freely use that for development. I will use the OpenJDK version 11 here, which is for long-term support, so I really recommend you to use the same. And we want to download this here. And then we click on save again, wait until the download is finished here. And once it is, we want to click on run again and install this JDK. Let's open this window here. We can click on next at the first screen. We want to accept the license agreement, click on next again. We can change the location again. I will leave it as it is here. Click on next, and we can click on install. And once the setup is finished, we can simply click on finish and go back to our IntelliJ program here and click on Kotlin, because we want to create a Kotlin project here. And we will just choose this first option here, JVM, that stands for Java Virtual Machine. And that is just special to Java and Kotlin. So what actually happens is it will simulate an environment in which our program runs, so a virtual machine, and that will just allow us to run our program everywhere. So on macOS, Linux, Windows, everywhere. Then we simply click on next here. We can give our project a name. Let's just call that Kotlin -crash -course. And you can see the project will be created at this location here, and we can select a project SDK here, and that is exactly this JDK we just installed. So right now we don't have anything selected here. We want to open that and click on Add JDK, and then it will open our file system. Now you need to go to the location you installed your JDK to. So in my case, program files, adopt open JDK, and we want to select this folder, so JDK minus version 11, blah blah blah. Then we can click on OK, and you can see now we have Java version 11 selected here, and it should look the same for you. Then we can simply click on finish, and IntelliJ will create our project for us and open it as well. So let's actually wait a little moment, maximize that. And you can see we get a tip of the day. If you don't want these, you can simply check this mark, don't show tips, and close this window. So what we now want to do is we want to go to project on the top left corner here. This will open our project hierarchy. And that is actually a lot of stuff that we don't need to consider here. We only worry about this src folder. That stands for source, and we just put all of our source files, so our Kotlin files in that, in which we will put our actual code. And in this src folder, we actually now want to create our first Kotlin file. So we right click, go to new, and select Kotlin file or class. And you can see we have several options here to choose from. We just want to create a plain Kotlin file, and most of the other options will get clearer what they actually mean during this course. And we will call this file a main because this file will contain our so-called main function. In Kotlin, every program needs this main function, and that is just the entry point for our program. So somehow when we actually run our program here, it needs to know where it should start in the code, and that will always be the main function. And we can create that main function here. Let's make a little lines of code here, little space, by simply writing fun. So for function, then the name of the function, which must be main in this case, followed by 2 parentheses that don't contain anything, and after that curly brackets. So this will be the function our program will jump to when we launch it. And between those 2 curly brackets, we will now put the code that we want to execute when this main function is called. And the mainstream example here for almost every programming tutorial is the so-called Hello World program. So just a program that displays the text Hello World. And we can very easily do that by writing print line, so println here. And then in quotation marks, we just write the text we want to print. So printing doesn't actually mean printing here in your printer. Instead, it means to print something to the console. We won't do any graphical stuff here. Instead, we will just have a console in which we can output text basically. So for example, Hello World. And now if you have done that, we can go to the top side here, click on run, and click on this play symbol which says run. And then we want to select main KT. So we want to run this main Kotlin file here. Click on that. And then IntelliJ will build our project. So building means it will just take all of our resources, all of our source files, put them together to an executable file and run it. And if you now take a look at the bottom here, you can see it says Hello World. And that is actually your very first Kotlin program. So what else can we do here? Let's remove our println statement here again. And instead, what we will do is we want to create a variable. So that is just a placeholder for a value here. And we can declare a variable by typing var. And then we need to give that variable a name. Let's just call it x, for example, followed by a colon. And now we need to specify the type this variable should have. So in Kotlin, we can have several types we can assign to those variables. So it could either be an integer number, it could be a decimal number, it could be just a character, or for example, a Boolean. A Boolean is just a variable that either is true or false. So let's actually just start with integer numbers here. To specify that this variable x is now an integer, we need to type int after that. And now we can write an equals sign here and assign a value to that variable. So for example, 3. And that equals has now a different meaning than in math. So if you're a little bit familiar with math, then this would mean that x is the same as 3. But what we actually mean in programming with this equals is that we set the value of x to 3. So we say x is now 3. And now we could, for example, just write another println statement here in the next line, println, and in here we could write the value of x is followed by a $sign and then x. So that $sign will just insert the actual value of x. So it won't just print x to the console as it is here. Instead, it will take a look which value is saved in that x variable, which is 3, and then insert it here at that place. So if we now rerun our program, which you can also do in the top right corner from now on, click on this play symbol, take a look in our console, then you will see now it prints the value of x is 3. And if we would now want to assign a new value to our x variable, then we could simply do that afterwards, for example, and just use x. So this time we don't need that var again, and we could just assign a new number to it, for example 4. And then we could print a line again, the value of x is now, and again use that $sign and x, rerun our project, our program here, take a look in the console, and you can see first it prints the value of x is 3, and afterwards it prints the value of x is now 4, because we changed it. And actually there is another type of variable we can declare here. So for now we use that var keyword. So everything in Kotlin that is highlighted in this orange here is called a keyword. And another keyword for this would be val. That will also declare a variable in the exact same way, but this time you can see we get an error here. If we hold on to this, you can see val cannot be reassigned. And that is the special thing of a val. That means once we declare that val, so that number here, we cannot change it afterwards. So this here won't work anymore. And we can also remove the second println statement here. But this will run exactly the same way as it did before, because that is just another way of declaring a variable. And you should really prefer making your variables a val instead of a var if you don't need to change it later. It's just good programming style to make your variables not changeable if they don't need to be changeable. And we also actually don't need to explicitly define that this is an integer. So if we leave this away and the colon as well, then you can see this works as well. So we don't get any error here. And the reason for that is that Kotlin is smart enough to recognize that we set the value of x equal to a whole number, and then it automatically knows that we wanted to declare an integer number here. So let's actually see which other types we have here other than integer. For example, we could attach a capital L here after the 3, which would make our x a so-called a long. Long is just a format that can save much bigger numbers than integer. So integer is a 32-bit number, so it can save up to 2 to the power of 32 numbers, and a long is a 64-bit number, so it can save 2 to the power of 64 different numbers. Then we could make that x variable here, of course, also a decimal number by attaching a dot, 33 for example, and that works. That is now called a double if we write it in that format. But we also have another type of decimal numbers which is called a float by attaching this f after that number. A float and a double both represent decimal numbers. A double is just more precise than float, but it also takes more memory. So if you don't need that precision for decimal numbers, then you should always prefer float. So let's actually create some more variables here so you can remember that better. First of all, we had our whole number, which we just declared by setting it to any number. Then we had our big number, which was a long, so we would set that to 3L in this case. And you can see we can just make that number very big here. I'll just leave it at 3 here, and also remove that print line statement because we don't have that variable x now, so it will give us an error because it doesn't know it. And then we also have a precise decimal, which is 3.33 for example. We have a normal decimal which we set to 3.33f. We have, as I said, Boolean expressions, so either true or false. So for example, val I love vegetables is equal to false. Or we could use val I love pizza, and we set that equal to true. And by the way, maybe you noticed how I write these variables. So all of these start with a lower letter, followed by a capital letter for each starting word. And that is called camel case, and you should always adapt to that type of spelling for your variables. That is just a naming convention in Kotlin, and in bigger projects that makes it very easy for you and your team to immediately see which is a variable, which is something else. And we also are able to create simple characters. So val I am a letter, for example, and we need to make these in these single quotation marks. For example, set that to A. So what else cool stuff can we do here with these variables? I will actually remove those again, because what I want to show you now are so-called arithmetic operators. And I'm sure you know these from school. Those are just used for addition, subtraction, multiplication, and division. And of course, we have access to them in Kotlin as well. So what we can do is we can create a val x, and set that to, for example, 3 times 4 with this asterisk. And if we would now print that again to our console, so print line, the value of x is $x, and run our program. Take a look in our console in the bottom here. You can see now it prints the value of x is 12 because it calculated 3 times 4 and saved the value in our variable x. And of course, we can also replace that with a plus, with a minus, with a divide by. But here we actually need to take care, because if we would run our program here, it will print the value of x is 0, even though 3 divided by 4 is not 0. Instead, it's 0.75. But since we use integer numbers here, so whole numbers, the result of that division can also only be an integer number. And what Kotlin will do in this case is it will just throw away the decimal part. So it will throw away the 0.75 and just keep the 0. So if we would actually need an accurate decimal result here, we would need to make these variables, for example, a float by attaching an f afterwards. So if we would now rerun this and take a look in the console, you will see now the result, so the value of x is 0.75. So that is now correct. And another arithmetic operator that is not obvious is called modulo. So what we could do is we could write 10 modulo 3, so that is represented by this percentage here. And what that would mean, or what that would do, is it will take the 10, divide it by 3, and save the remainder of that division in x. So in that case, it would actually save 1 in x. And that is, for example, something you need if you want to check if a specific number is even or odd. So then we would just use, let's say we want to check if 10 is an even number, then we would use 10 modulo 2. So that would check if 10 is actually divisible by 2, because if the remainder of that division is 0, we know 10 must be an even number. And if it is odd, so if it is 1, then it must be an odd number. But let's actually now take a closer look at booleans, so these true or false values. And I want to create a boolean here called am I an adult, which are set to true. And I will create another boolean, am I a programmer, which are also set to true. And now with these booleans, we have the possibility of so-called logical and comparison operators. So if we would write val, am I an adult programmer, which is only true if both of these booleans is true, then we can set that equal to am I an adult, and so a double and, that is important here, am I a programmer. So this will just check if this is true and if this is true, and only if both are true, it will assign true to this. So what we will do is we will remove that here and instead just print the value of am I an adult programmer, run our program again, take a look in the console, and you can see it now prints true because both of our values here are true. And if there is an option to and check, there is also an option to or check. So if one of these options is actually true, if this one or this one is true, or if both are true. And we can do this by writing two of these lines. I don't know how they are called, but that is basically an or check. So it will check if this is true or if this is true. And if one of these is at least true, it will also assign true to this boolean. Then these were logical operators. Now we also have comparison operators. So as the name says, we want to compare something. For example, if am I an adult has the same value as am I a programmer, and only then we want to assign true to this variable. And we can do that with a double equals here. So that is important. That is a different equals than this one. This single equals means we want to assign the value of this here to this variable. And this double equals means we want to check if this is equal to this. So to make that a little bit clearer, we can actually put that into parentheses. They are optional here, but maybe this helps you to understand how this actually is evaluated. And if there is a way to check if two variables actually have the same value, there is also a way to check if two variables do not have the same value. In that case, we wouldn't write equals equals. Instead, we would write this exclamation mark equals. So that means this variable is not equal to this variable. So let's just run this program to demonstrate that to you. And if you take a look in the console now, you can see it prints false, because it will take a look at am I an adult, which is true, and it will take a look at am I a programmer, which is also true. But only if this variable is not equal to this variable, it will assign true to this variable. And because those two are actually the same, and we check if they are not the same, the result will be false here. And one last operator we can use here is the single exclamation mark operator, which will just negate a boolean. So for example, we could attach that to the start of these parentheses, and that will just negate that whole expression. So if that is true, this will make it false, and if that is false, then this operator will make it true actually. So as you saw, if we when we didn't have that, this returned false, and if we use that now and run our program, it will negate that whole expression again, and now it will print true again. So let's actually take a look at strings next. We actually already used those strings before without much thinking about it. So I will remove all of that code here again and create a string, which is actually nothing else than just a text. So val string is equal to, and then we use those quotation marks again, which we used in our println function. And here we can just type anything. So Kotlin is the best language, for example, and then simply use println and print the string instead. So before we just used that string here and used it directly in the println function, this time we just save this text in this object here and then print that value of that object basically. So exactly the same as we did it with these variables before. And there are also a bunch of functions you can call on that string object by writing a dot. For example, we could convert that to uppercase. And if we would now run that, take a look in the console, then it will just print our string in all uppercase here. And that's actually already the whole magic of strings. Let's get to a very important concept next, which you will find in every programming language out there, the so-called if conditions. So very often in programming, we just need to check if a specific condition is true. If it is, we want to execute this code. If it's false, we want to execute this code. So for example, if we have a variable x here and set that to 1 + 1, and now we want to check if that is actually 2. So we write if, followed by parentheses, and now in these parentheses we have to write the condition. So that must be a boolean here, because we either want to check if something is true or false. And we could, for example, check now if x is the same as 2. So x == 2. And then in curly brackets afterwards, we can put the code that should be executed if this condition is actually true. So in that case, we could write a println statement, x is 2. And if that is not the case, we could, for example, attach an else if. So we can specify another condition. So this check is actually done if this fails. So if x is not equal to 2, then we could check if x is equal to 3, for example. And curly brackets again. Then we would print x is 3. And then we also have the option to just put an else block here. So this will just check if x is 2. If it is, it will execute this code. If it is false, then it will jump into this else if block. We'll check if that is true. If that is false, it will just jump into this else block. So in all other cases, it will do whatever we put into this block of code here. So in here we could write println x is not 2 or 3. So if we would now run this, take a look in the console again, then you can see it will print x is 2, of course, because 1 + 1 is obviously 2. If we would change this to 1 + 2 and run our program, it will print x is 3, because that was false, but that was true. And if we would set that now to 1 + 3, correct me if I'm wrong, but I guess that is 4, And 4 is not equal to 2, 4 is also not equal to 3, so what it must do is it will jump into this else block. So if we would now run this again, it will print x is not 2 or 3. And the cool thing about if conditions in Kotlin is that we can use them as expression. So what that means is we could create a variable y here, and we could set that equal to an if condition. So for example, if x is equal to 2, then we want to assign the value 2 to y, and else we want to assign the value 3 to y. So that is also a way how we can use if conditions here. And next it comes to a very Kotlin specific feature. If you know Java, then you will know null values and null pointer exceptions. So a null value is basically just a value that we can assign to a variable that will make the variable contain nothing. So it's basically just an empty value for that variable. And that was a big disadvantage of Java, because in Java it could happen that our program crashed if we access such a variable that contains nothing. And in Kotlin we're still able to do that, because sometimes we just need to set a variable to null. And Kotlin will make sure that when we press run, nothing could potentially crash our program. And that is called null safety. So Kotlin is a null safe language and Java is not. So let's actually remove our if statements here again and declare an integer variable that we will just set to this null value I talked about. So val x again, and this time we explicitly need to declare the type with this colon again, because a type is not nullable by default. So we either have nullable types or non-nullable types. And if a type is nullable, then we have the option to assign this null value to it, so to make it contain nothing. And we can do that by first specifying the type this variable should have, in our case just int, and then appending a question mark after that. And that will now allow us to set that variable to null. And that is an example that might not tell you very well what this can be used for. So let's create another val here, and we want to accept the user input now. So user input, so for now we only printed something to the console, but now we actually want to take input from the user and do something with that. And we can set that equal to readline, and you can see that is the type this function will return. So the type that our user input variable will have, and that is a nullable string, so a text that is nullable. And let's actually make a little calculator that can only add numbers by calling this number1, and then we can copy this line, paste it below, call this number2, so we now accept two user inputs, two numbers, and then we want to save the result of the addition of these numbers in this result variable. So we set result equal to number1 plus number2. And right now this won't work, because both our number1 and number2 are of type string. And Kotlin won't do a real addition here, because it will treat those variables as strings and not as integer numbers that we really want to add here. And because of that, we need to convert these strings here to an integer. We can do that with the .toInt function here, and also the number2 should be converted to an integer here. And we get two errors here, because this readline function could potentially return this null value if something goes wrong with that function. And in that case, we just need to make sure that at this part here, these values can't be null, because Kotlin doesn't know how to add null values. It only knows how to add numbers. And to make sure that something is not equal to null, we can use this question mark here before the dot. So that will only execute this toInt function if this number1 is not equal to null. But in this case here, this won't work, because if this would be null, it would still replace this expression with a null. And then it still wouldn't know how to add this to another number. So what we could do instead is use that double exclamation mark operator, which will just assume that this number1 is not equal to null. So we basically tell Kotlin, trust me, we know this is not null. And if it would be null, then our program would still crash. So that is very similar to Java. We would do that here as well. And if we now, print that result here, print line result, and run our program, take a look in the console, we can now enter two numbers, for example 4, enter 5, and you can see it will print the result of those two numbers, so 9. But I don't recommend using these double exclamation marks here because they could potentially make your program crash, which you want to prevent, of course. Instead, we will use one more operator here after this readline function, which is $:, and now we can specify another string that should instead be assigned to number 1 if this readline function returns null. So in that case, just a 0 as a string and another 0 here. And that will just return or assign the result, so the user input, to this number 1. But if something goes wrong with that function and it returns null, it will assign a 0 instead. The next concept I want to show you are actually so-called lists. So those are data containers we can use to save a bunch of variables in. So we could, for example, create a shopping list here and set that equal to a list of. And in these angle brackets, we now need to specify the type of the variables we want to save in that list. For example, a string, because a shopping list usually contains texts. And in these parentheses, we can now list all of our items we want to have in this list. So for example, a Lamborghini, a penthouse, and a Rolex, just a normal purchase as a programming YouTuber. And now if we want to access the items in that list, we could, for example, print one of these in a print line statement and use our shopping list followed by square brackets. And you can see that now takes an index, which is basically a number that refers to the item we want to print out. So lists actually start with the index 0. So the first item has the index 0, then the second item, the index 1, index 2, and so on. So if we would have more entries, then it would just go on like this. For example, if we want to print the first item, we use shopping list at the index of 0. If we now run this, take a look in the console, you will see it will print Lamborghini. And here you need to be careful. So if you would replace that 0 with a 3, that would mean we access a shopping list at the index of 3, which doesn't exist in our list because the highest index is Rolex with the index of 2. So that would make our program crash. So you will always need to make sure that you don't access an index of a list that doesn't exist. Now, there are two major types of lists we can have here in Kotlin: immutable lists and mutable lists. So right now that is an immutable list. We cannot add items to that list or remove items from that list, or also we cannot change items, so the value of items, after we created that list. But we could replace this list of with mutable list of, and that would allow us to do this. And by the way, we also don't need this string specification here because we just put strings into this list, so Kotlin will just recognize that we will have string values in that list. So now we declared that as a mutable list, which means we can always add and remove entries of that list. So as you can see, the highest index is Rolex with the index 2. But what we could do now is we could use our shopping list dot add to add an item to that list, which will just be appended to the last item of that list, so after Rolex. And we could just specify another string here. So for example, a Ferrari. And now if we run this, you can see that it will print Ferrari, because that is now at the index of 3. So otherwise it would crash if we wouldn't have added this item here. But since we did, the list actually has the index 3, and then we can print it afterwards. But what if we actually wanted to print all of these items in our list one after another? And that's where loops come into play. There are two major types of loops, the while loop and the for loop in Kotlin. And loops will just execute a specific action several times in a row. So let's start with the while loop. Let's use a while loop to print out all these items. We do that by writing while parentheses, and in these parentheses we need to put a Boolean condition that must be true, or at least as long as this is true, the while loop will repeat a specific piece of code. So what I will do here is I will define a counter, so var counter, and set that to 0 because our indices start at 0. And this also must be a var here because we want to increase the counter. So we want to change the value of that later. And as long as this counter is less than our shopping list.size, so that is equal to the amount of items we have in our shopping list, then we want to execute this piece of code. So it will check if the counter is less than that, then execute that code. After it executed that, it will check again. If the counter is still less than that, it will still execute that piece of code until this condition starts to become false. Then it will jump out of that while loop and continue with the code afterwards. So what we want to do is we want to print a line with the shopping list at the index of counter this time. So this counter starts at 0, and we just increase this counter in each iteration by writing counter plus plus. So that is actually just a short way of writing counter is equal to counter plus 1. We can just write counter plus plus, and that will just increase that variable by 1. So we'll just start with counter equal to 0 for the first index of that list. Then it will print that first index, it will increase the counter, so in the next iteration this counter will be 1, so we will print that item instead. Then we will increase it again, so we print that item instead, and so on and so forth. So let's actually just remove this print line statement here and run our program and take a look in the console. So now you can see it prints all the items in our list as expected. But actually there is a much easier way to achieve the same behavior here, and that is by using the other type of loop, so for loops. Let's remove this loop here and write for instead, parentheses. And now with for, we can simply just loop over the whole list, so we can directly get references to the single items of that list. So we can use for. Now we need to define a name for each item. So shopping item, for example. For each shopping item in our shopping list, we want to execute this piece of code. And that is actually very readable in my opinion. So shopping item will actually start with Lamborghini, then in the next iteration it will be Penthouse, then Rolex, and so on. So we just go through each item in our shopping list, and now we can simply print that item. So we just want to print a line with the shopping item. And if we now run our program again, then you will see it is the same result as before. And there's also another feature we can use with for loops. So let's remove that for loop again. We could loop over a so-called range. So that is just a range of numbers or of letters or whatever you want. So for example, I, which is usually a name for counter variables in programming, for I in, and now we can specify a range of numbers. So for example, from 1 to 100. That will just assign the values 1, 2, 3, 4, 5, and so on to I, and execute this piece of code 100 times. So if we would now print I and run our program, then you will see that Kotlin will print 100 numbers here to our console. And that are already the basics for loops in Kotlin. The next thing I want to show you is the so-called when expression. So we can create a val x here and set it to 3, for example. Now we can use a when x, open curly brackets here, and that is very similar to if conditions, actually just in some scenarios a shorter way to write that. So for example, we could check if x is in the range of 1 to 2. Then we make this arrow, and let's say in this case we want to print a line x is between 1 and 2. And then we could just add another statement here. If it is in the range of 3 to 10, for example, then we want to print line x is between 3 and 10. And for example, else, so in all other cases, if these two were false, then we just want to execute another piece of code. So if you want to write more lines of code, then you can also make these curly brackets here again. You don't have to write that in a single line as I did here. So just to show you that, we could also write print line here, x is not in the range of 1 to 10. And if we would now run this, then check the console, you can see we will get the result x is between 3 and 10, which is true because x is 3. And that is, as I said, very similar to if conditions, just in case you want to make all your if conditions depending on a single variable, so depending on this x, for example, here, then this when expression is actually a much shorter way to write that, instead of writing if x is equal to this, else if equal to this, else if equal to this, else, and so on. That is just a more beautiful way to write that, actually a better coding style. Now let's get to a very important topic, which are functions. So I will actually remove all of our code here in our main function. So that is already a function that we created here, but we had to create that to specify an entry point for our program. But we can also create our very own functions that just do some stuff for us, and then we just need to call that function name once in our program to execute the whole code of our function. So let's, for example, create a function down here, and that is done outside of the main function, and we call this print 10 numbers, for example. So just a function that will print the numbers 1 to 10. We will just use a for loop for that. For I in the range of 1 to 10, we want to print I. And that is, as you can see, the same syntax as we had it for the main function, just the function keyword, the function name, which also should start with a lower letter, and then the rest in camel case. Parentheses, why we actually have to do these, I will explain soon. And in this block of code here, we just put the code that should be executed when we call that function. And we can actually call that in our main function, so that is still the entry point of our program, by writing print 10 numbers. And if we now run our program, then you will see that it will actually print 10 numbers. And such functions are of course very useful if you have a piece of code in your program that you need at very many places in your program, because you don't want to write the same for loop here at every place. That would just increase your lines of code by a lot and make it very messy. Instead, you just define a function. So you just need to call this function a single line to execute this piece of code over and over again. And of course, in bigger programs, these functions can become very big as well. So why do we actually have these empty parentheses here? The reason for that is we can use these to specify parameters for our functions. So if our function would rely on outside input, so for example, if we would want to give a value that we only have in our main function to our print 10 numbers function, then we could do that in these parentheses here. And let's actually specify another function here. Let's make it up here. That just checks if a number is actually an even number. So for example, function is even, and now we of course need to pass the number to this function. We want to check if that is actually even. So we just type number colon, and here we need to specify the type of that number. So this time this is not optional, which is an integer number. And then we can open this function body with these curly brackets again. And now inside of this function, we can access the function that we pass as a parameter. But this function should actually also return something, because we pass this number from the outside and we want to check if that number is actually even or not. And then we also want to be able to get the result of our isEven function from the outside. So we want to know if that is actually an even number or not. And that is where so-called return values come into play. So our function can actually return something. So we give it some inputs in this parameters list here, and our function just does its job and then gives us the output. And we can specify the output after these parentheses here by writing colon again and the type we want to return here. So in this function, we want to check if the number we pass as a parameter is even or odd. So we can simply return a variable of type boolean here, because either this number is even or it's not even, so either true or false. And to actually return something in our function, we use the return keyword. And what do we actually now want to return? Well, now we want to check if this number is even. And if you remember correctly, we can use this modulo operator I showed you at the beginning of this course. So we could check if number modulo 2, if that is equal to 0. So we divide our number by 2, and if the remainder of that division is equal to 0, that means our number is divisible by 2, and that means it is even. So to actually be able to use that function, we go into our main function again, and now we actually want to be able to save the result of this isEven function in a variable. So because that returns a boolean, we can save that boolean in a variable. So for example, val x again, and set that equal to isEven, so our function, and this time you can see if we press Ctrl and P, then it displays the parameters we need to pass. This time we need to pass a number, so the number we want to check if that is even or not. And let's just check, for example, if 5 is an even number, which it is not, of course. So that will just check that if 5 is an even number, and the result of that function, so the boolean, will be saved in that x variable here. So afterwards, we can simply print a line with x, run our program, and it will tell us if the number 5 is even or not. And you can see it prints false, which is of course what we expect here. And by the way, you could also just write several parameters in here. So if you have more of these, then you can just separate these with a comma. So for example, we could have a second number here, which is also of type integer. But in this function here, this wouldn't make much sense. In Kotlin, we are also able to use so-called default parameters. That means we assign default values to these function parameters, and then we don't have to pass a value for those. So you can see when we call this function, we pass the value 5 to it. But with default parameters, we can specify a default value. And we can do that by simply setting that number equal to anything, for example, equal to 10. And that will use the value 10 for that number parameter if we don't pass a parameter for that number. So in our case, this wouldn't change anything because we call this isEven function with the parameter 5. But in this case, because we specified this default parameter here, we could also leave the 5 away, and this would also work. In this case, since we didn't provide a parameter on our own, it will just use the 10 by default. So this will just return true because 10 is of course an even number. And for readability, we could also use so-called named parameters. And that means if we call this function here, our isEven function, we can explicitly specify the name of this parameter we want to assign something to, and just set it equal to any number here in this case. So we use number is equal to, let's say, 5 again. This is optional, you don't need to do that, but as I said, that just improves readability a little bit. So if you like to do that, then you can do that. And another very Kotlin specific feature here are so-called extension functions. So those will be functions that extend an already existing type. So for example, integer, string, or whatever you like. And that is really a feature that not many languages have, but Kotlin does. So let's actually create a function, an extension function isOdd, to check if a number is odd, by simply specifying function again, so the keyword for that. And now we want to specify the type we want to extend. In this case, it's integer, because we want to be able to call that function on integer numbers. And after that, we write a dot, followed by the function name, so isOdd. And this time, this function doesn't take any parameters. So for isEven, we needed this number as a parameter, but this time, instead we use the number we call that function on. And it will get clearer soon when we actually use that function. So it will still return a boolean, whether this number is odd or not. And this time it will return, because now we don't have that number we can refer to. Instead, in extension functions, we use the keyword this. So this will actually be a number here. And we can use this modulo 2 is equal to 1 this time, because this time we want to check if the number is odd. And now to call this function, we can, for example, specify a y variable here, set that to 3, and then print y dot is odd. You can see now, after we wrote this integer variable first and wrote a dot after that, we can now call this isOdd function on that. And that is just a different behavior as for this is even function, but in the end it's the same. Okay, so the next big topic I want to explain here are so-called classes. Classes really help us to structure our code better, make it better understandable for us and also for others. And in general, a class is just a blueprint for something. And if we want to create such a class, we usually do that in its own Kotlin file. So outside of this main.kt file, we want to go to our src folder, right click on that and create a new Kotlin file or class. And I will simply create a simple animal class here because I think that is very good for educational purposes. We select class here, so we'll make sure that you have class selected and then press enter. Okay, what can we now do with this class? Well, we could give it some properties. We can think about which properties or which characteristics does each animal out there have. For example, each animal has a name. And then we could specify parentheses here. And in these, we could specify a val name, which is of type string. And now it's actually important to understand the difference between a class and an instance of a class. So this, what we did here, was a class or is a class. So we just specified each animal needs a name. But an instance of a class is basically that blueprint applied. So you can think of that if you buy a table, then you will also get a manual that describes to you how you can build that table, how you can construct that. And that manual is the actual class, and that table, that outcome, is an instance of the class. And that's also what these parentheses here are called for classes. That is the so-called constructor. Because whenever we construct such an animal, so whenever we create such an instance, we need to specify a name for that animal. And let's actually switch back to our main.kt file and create an animal here, remove this code, and for example, create a dog. And we set that equal to animal. And now in these parentheses, you can see we need to specify a name for that, which is just dog. And what we could do now is, right now nothing would happen here. We could instead go to this animal class, inside of this class body, these curly brackets, and specify a so-called init block. So that is a block of code that will be executed whenever we create an instance of this class. So here we actually create such an instance. And for this animal, for this dog here, we will execute this init block. And we could, for example, just use print line here and print hello, my name is, and then simply insert the name that we passed here when we constructed that animal. So that will be dog here. And if we now run our program and take a look in the console, you can see it prints hello, my name is dog. But the really cool part about classes is now if it comes to inheritance, because that is possible, that we can define a class hierarchy and that some classes inherit from other classes. Let's actually do that and create a new class in our src folder, new Kotlin file class. And now I will create a class only for dogs. So call that dog, select class here. And to specify that this class now inherits from animal, because each dog is an animal, we write a colon after that class name, followed by the class we want to inherit from, so animal, and call the constructor on this animal. So when I say call the constructor, I just mean write these parentheses and specify the parameters we need to construct an instance of that class. So now we need to specify the name for each dog we have, and that is just dog. And right now we get an error here, because if we want to inherit from a class, we need to define that class that we want to inherit from, so our animal class, as a so-called open class. And then you can see that error goes away. But what is this inheritance stuff actually useful for? So you can see in our animal class, we defined that name property here. And for example, we could also specify another property, for example, for the amount of legs this animal has, so leg count, which is of type integer, of course, and let's set that to 4 by default. And then you will see now, if we take a look at our dog class, and for example use the init block here as well, that we have access to the properties we defined in the parent class, so in our animal class. So if we write leg count, you can see we have access to that variable, even though we didn't declare it in this dog class. But since we did declare it in our animal class and our dog class inherits from animal, that means our dog class will also have all the properties that this animal class has. And that means we can also access the lag count here. But I actually want to remove this init block here in our dog class again. And instead what we can do is we can also create functions in these classes. So for a dog, we could, for example, create a function to bark, because not every animal can bark, but each dog can bark. So we don't specify this function in the animal class. Instead, we specify it in the dog class. And here we can just print a line, woof, like this. And now we can only use that function if we explicitly created a dog, but not if we created an animal. So let's actually see how that works in the main function here, in our main file. Here we created a dog, but right now we set it equal to an animal. But let's actually specify that this is equal to a dog now, because we have that dog class, and now this parameter is invalid because we already set that in our dog class here, when we called that animal constructor here. Here we already said that each dog must have this name dog. So we don't need to specify it here. And now we can use that dog and bark. So let's try that. Run our program. Take a look in the console here. You can see, first of all, it will print hello, my name is dog, because it will still go inside of this init block of the animal class. But then we call this bark function and it will simply print woof. And let's actually also create such a class for a cat, just for practice. We go to our src folder, right click, new Kotlin file class, call that cat, select class and press enter. This will also inherit from animal. This time we give it the name cat and we give it a function meow this time. So we simply print a line and print meow. And then we can go back to our main KT file again and also create a cat here. So val cat is equal to a cat. And then we can use cat.meow. So on this cat object, we don't have the possibility to bark, and the other way around, we don't have the possibility to meow on a dog object. And that just lets us model real life scenarios really well in our program code, which is usually pretty abstract. So if we now run this, you will just see what we expect here. First of all, the dog will print its stuff and then the cat. But right now we have the problem that we can also still create an instance of an animal. But actually we don't want that, because in nature nothing is just an animal. Everything is just a specific animal. So we only want to be able to create dogs, cats, but not just an animal. And to fix that in our code, we just need to go into our animal class and make that not an open class. Instead, we make it an abstract class. And that just forbids it for us to create instances of this animal object. So if we go to our main file again and would try that again, val animal is equal to animal, then you see we get an error here. Cannot create an instance of an abstract class. And these abstract classes are mainly just used to just model behavior that we want to have in the subclasses, so of the classes that inherit from this animal class, cat and dog, but we don't want to be able to create an instance of an animal. And we can also use this abstract keyword to create functions we just want to have in these subclasses. So for example, you can see in both of our cat and dog class, we have a function that actually makes a sound from that animal. And only the type of sound differs, but not that both these animals can make a sound. So what we could do is we could define an abstract function here, make sound, and we don't implement this function here. We don't give it a body because it is abstract. And in our cat and dog class, you can see we get an error because now Kotlin wants us to implement this function in the subclasses. So whenever we make a function abstract, the classes that inherit from that class, so cat and dog, must implement this abstract function, but they can implement it in their way. So we could simply remove this And this would be an override function this time, because we override the behavior of the parent class and we call it make sound. And then the error will go away. And we can still specify for the cat that it will make meow, and for the dog that it will make woof. So if we use override function here as well, make sound, and we really have to give it the same name as we did it in our parent class, otherwise this won't work. But right now we just model a behavior that every animal needs to have a function that makes a sound, and in each class that inherits from animal we just give this function an implementation to specify how this specific animal makes its sound. Okay, and as a really last thing about classes I want to show you here are so-called anonymous classes. So those actually allow us to kind of create instances of abstract classes, so they don't really create that instance, but we can create a temporary version of a class by using anonymous classes. So we don't have to create that anonymous class in its own file. Instead we can go back to our main KT file, remove this here, and for example, let's say we want to create a bear, but we only want to be able to access that bear inside of this main function, and we don't need it anywhere else in our program. Then we can make that bear by using an anonymous class, and that can be done by creating a val bear is equal to object colon. So with this we basically create a temporary object of a class, so a temporary class kind of, that inherits from animal. And you can see now we need to specify the name for that animal again. Let's give this a name common bear, and afterwards we open curly brackets again, just as we did it for the other classes as well. But since animal contains an abstract function make sound, we also need to implement this function inside of this anonymous class here. So we can simply type make sound, and IntelliJ is smart enough to suggest that. We can simply press enter and it will autocomplete that. And then we can simply write a println statement in here with roar. And if you have problems understanding all that class stuff as a beginner, then really don't worry. That is not an easy topic here. That just gets clearer over time if you apply these principles on your own. But I just find it important to just mention that these topics exist. But of course I can also not go into too much detail in this rather short crash course. Okay, so next I actually want to talk about so-called exceptions. What are exceptions in Kotlin? Those are basically events that occur before or when our program actually crashes. So let's actually remove this to clarify that a little bit. If you think back to when we actually accepted user input. So for example, we have a variable here called number, and we set that equal to readline. And in case that readline function returns null, we want to set that number to a 0 as a string. That is nothing new for you. But if we use that number and convert that to an integer, then what actually happens if what we enter is not a number or is not convertible to a number? So because readline takes in a string, that means we could type anything in there. And if we would now run this and take a look in our console, then it will expect a user input by us. So if we type a number, everything is fine. But if we write hello, for example, then Kotlin of course doesn't know how to convert hello to a number. So if we now press enter, you'll see that our program will crash and it will throw an exception. You can see number format exception for input hello, because it doesn't know how to convert this hello string to a number. And of course, if we work on a real project, then we want to prevent that our project or that our program can just crash because the user entered a number incorrectly. That wouldn't be good. So how can we actually prevent that? And the answer is with a so-called try and catch block. So with that, we can simply specify something that we want to try. So in our case, we want to try to convert a number to, or want to convert a string to an integer rather, and then we will have a catch block where we can catch an exception. So in case such an exception, for example this number format exception, occurs during this conversion from string to integer, then we can catch that exception and execute another piece of code that we, for example, can display that the user entered a string that is not a number. So let's see how that works. We could write a val here and call that, for example, parsed number. And we set that equal to try, press enter here. And in this try block, we now specify what we want to try. So we want to try to parse our number that the user entered in the command line, and we want to convert that to an integer. So if this succeeds, so if this number is actually convertible to an integer, it will just assign the integer number to this parsed number. But if this fails, we instead go into this catch block here. And here we can specify an exception. So e colon of type exception. We choose this Kotlin exception here and press enter. And in here, we can now specify a value that should be assigned to this parsed number instead. So in case this number is not convertible to an integer, we will just assign another number to this parsed number. So for example, just 0. In case this succeeds, we will just pass the parsed number to this parsed number, so the actual converted number. And if this fails, this integer conversion, we will assign this 0 instead. And if we wrote print our parsed number afterwards and run our program, take a look at our command line here. It now expects an input of us. So for example, we could type 5. If you now press enter, you will see it just prints out whatever we entered here. So 5 is a number, it is convertible to an integer. But if we run this again and we type something invalid, for example, hello again, and press enter, this time it doesn't crash. Instead, it will simply print out 0 because it jumped into this catch block and assigned the 0 to this parsed number instead. Okay, and as a really last topic of this course, I want to give you a small introduction to so-called Lambda functions and generics. And that is really not a topic that I can fully cover in 10 minutes. So if you don't understand that in detail right now, what I will do, then don't worry about that. It will just get much clearer if you gain experience with Kotlin. Those are not easy topics, but I still want to show you what is possible with Kotlin and how you can actually use that. So first of all, Lambda functions. What are Lambda functions? Those are functions that we pass as a parameter to another function. And now intuitively you might think, why would I ever need that? And that is pretty useful actually. So if we remove that, there are some predefined Lambda functions in Kotlin that we can use. For example, if we create a list, val list is equal to list of, let's put in some strings here, Kotlin, comma is, comma fun. Then what we could do is we could now count elements in this list according to a rule that we define on our own using a Lambda function. So that means we could write val count is equal to our list dot count. And you can see this is a count function here that ends with these curly brackets, and those are Lambda functions in Kotlin. So what this means actually is it will go through this list here we created and count how many elements we have that fit to the rule that we will define here. So you can see we have access to a string here, which we can reference with it, or we could also give it a name, for example, current string, and then make this arrow afterwards. And now we can reference that current string this function is currently going through, and it will go through all of our strings in our list. And we have to return a boolean if this function should return true or false for a specific string in this function. And if it returns true, it will count it. So for example, we can just count how many strings do we have in this function that have the length 3, so that have 3 characters. And we could do that by writing current string dot length, which just returns the amount of characters a specific string has, is equal to 3. So that will just, as I said, go through this list and count how many strings we have in this list that have 3 characters. And if we would now print that, so print line count, and run that program, take a look on the command line, then you will see it will simply print 1, because we have 1 string in our list function, in our list here, that has the length 3, which is fun here. And in Lambda functions, we always just return the last line of this Lambda block. So it's not the same as we did here with that return statement. We don't write return this. Instead, we just leave this expression as it is, and the last line will be returned to this Lambda function. So what we did here is we just passed our very own function here with this block of code that affected the outcome of this function. And if we now want to create our own function, our own custom count function, for example, let's just write a function that does the same, but just to show you how we can do that on our own. We want to create a function here that extends this list type, so an extension function that extends lists of string dot custom count. And now as a parameter, that will take a function, so function, and this function is of type. Now it's becoming a little bit difficult. So first of all, we need to specify which type of parameter this function takes. So this function we pass as a parameter here will take a string as a parameter. So we just write a string in here in these parentheses, and that is the same string as we have here. So we will just loop over this list here and count all the elements for which this function we pass as a parameter returns true. So to actually specify that this function needs to return a Boolean, we use this arrow and specify the return type of that. And now our whole function here, our whole custom count function, should of course return how many elements we did count. So that is an integer number. And we specify that by simply writing int. And in this function, we can now take our list, which we can reference with this, since this is an extension function, the same way as we did it here. And we first of all want to create a counter. So how many elements we actually counted in this list so far. Then we want to use a for loop to loop over this list. So to loop over these items in this list, the strings. So for each string in this, because this is now our list that we call this function on. And for each string in this list, we want to check if the function we pass as a parameter actually returns true. So if function, which will now take that string that we are currently at, so we pass that as a parameter, if that returns true, so since that returns a Boolean, we don't need to make any comparison here. That is a typical beginner mistake, that you just compare that to true, but that is not necessary here. We can just leave that away. And then we just want to increase the counter by 1. And in the end of our whole function, we return our counter. So I will go through that one more time, because I'm sure that is super confusing if you're a beginner. We extend the type list of type string. So we extend the type of lists we have up here. We call this function custom count, which should just do exactly the same as this predefined count function, just that you see how we can create our own function that serves as a Lambda function. We pass this Lambda function here as a parameter. So the parameter is of type. This is how we specify a function type. So this function that we need to pass as a parameter takes in a string as a parameter, which is equivalent to this string here, and it returns a Boolean, which is equivalent to this expression. So this also either returns true if the current string has the length 3, or it returns false if it does not have the length 3. And this whole function, our custom count, returns an integer, which is the amount of items we counted for which this function was true. And in our custom count function, we just have this counter variable that we set to 0 initially, and we just go through all of our strings that we have in this list. And if we find a string for which our lambda function that we pass as a parameter returns true, we simply found such an item we want to count, so increase the counter by 1. And we could now simply replace this predefined count function with our custom count function, and it would work exactly the same. So for example, we could change this a little bit. We could make this greater than or equal to 3. And that should now return 2, because we have 2 strings that have 3 or more characters. And you can see that is exactly what happens here. And if we now want to be able to call this custom count function on any kind of list, not only on a list of strings, then we use so-called generics. That is basically just a type parameter. So we pass the type we want to call this function on. We can do this with these angle brackets, and usually we just call this type T, so a capital T. And then we can use that T, so whatever we passed for that, also in this list. So instead of string, instead of this string, and that's already it. So we just call this function here. We extend a list of type T, so just a list of any type, and then we have access to that type in this function. So this would now also allow us to call this custom count function on a list of integers, on a list of characters, of floats, of whatever. And that is of course what we want to be able to do. We want to be able to call this on any type, because the type doesn't matter if we want to count the amount of elements we have in a list. But that is it for this crash course. Congratulations that you followed through this long, and really, as I said, don't worry if you didn't understand all of it. And that is normal, especially the stuff that we worked with at the end of this course, so classes, lambda functions, all that stuff. There is much more depth into this topic actually, so you can go much deeper into these topics, and it's just not enough time to fully cover these in a crash course, but it's also not necessary to know them in its full detail as a beginner, because in my opinion you will just gain experience while coding, and the details you will actually learn on the fly. So if you ask me personally, what you should do next is, I would always suggest just to practice what you learned in this course, because just by watching you will learn nothing at all. So you really need to do something on your own to really learn something, and yet just write little functions. For example, a function that finds an item in a list and returns the index of it, a function that reverses a list, a function that checks if a specific number is a prime number, and all those little functions that are not too difficult but challenging as a beginner. If you are able to do these, then you will have some feelings of success. And really don't mind, if you liked my way of teaching, to check out my channel Philipp Lackner. I do all kinds of stuff, currently only using Kotlin, so you can really learn more detailed stuff here than I could cover in this crash course. And also, if there is anything you think I can improve on my way of teaching, then I would also love to hear about that in this video's comments. So thanks everybody who watched this far, and again, thank you Brad for giving me that opportunity to just teach my favorite language, Kotlin, and I wish all of you a very nice day.